Still section 2.3, part 4, video. And we're talking about domain of equations. And so let me just quickly remind you of this, and then I'm going to give it to you in a note. What two things can we not allow as far as whenever we plug our number in for x? What two things can we not allow in domain? We cannot allow division by 0, and we cannot allow square roots of negative numbers. Those are the two things. All right, now let's take down this note, and then we'll do our examples. Very important note, very important that you write this whole note down. All right, here's the note. To find the domain of an equation, we will first solve the equation for y. Now, I'm not finished with that note. So we're going to first solve it for y. So in other words, this is what we're going to do. And I know this is not mathematical, but I'm just going to write it. So in other words, we're going to get the y by itself. It's going to be y equal, and it's going to be nothing but x stuff over here. That's what we call writing y as a function of x, or solving the equation for y explicitly in terms of x. So get the y by itself and the x stuff all over on the other side. That's the first thing we're going to do. Now continue the note. There are two instances in which the domain is limited. Number one, if x is in the denominator, we cannot allow any value of x that would cause the denominator to be 0. Number two, if x is under a square root, we cannot allow any value of x to make the radicand, R-A-D-I-C-A-N-D, to make the radicand be negative. Continue with this part 2. In other words, the radicand, R-A-D-I-C-A-N-D, the radicand must be greater than or equal to 0. Okay, now let me just kind of explain what you just wrote. All right, so here's what we're going to do. You don't have to write this down. Excuse me. What we're going to do is we're going to solve the equation for y. When we do this, if we have an x in the denominator or an x under a square root, if either one of these things happen, that means that your domain's probably going to be limited. Not always, but more than likely. Probably for us it will be. It'll be limited. Now, you say, well, Mr. Rayner, what if I have a problem where I solve it for y and x is not in the denominator or x is not under a square root? What if neither one of these things happen? Then the domain's not limited. What does that mean if the domain is not limited? It means that the domain then is all real numbers. So when you solve, this is all you need to remember for in here. When you solve your equation for y, if you have an x in the denominator, let me say it again. If you don't have x in the denominator, and you don't have x under a square root, if neither one of these occur, then in that case, the domain is all real numbers. All right, so what do we do if we have an x in the denominator? We said that, you don't have to write this down, the denominator cannot be 0. So here's what we're going to do. We're going to find out what makes the denominator 0, find out what that is, and then you can't use it. For instance, let's go back to the one I had up here, this one right here. If you let x be 4, the denominator becomes what? 0. 7 over 0. So what we would do is we would say, okay, you can't use 4. So then what would the domain be? All real numbers except 4. So you find out what makes that be 0. Well, that's easy. Solve that for x, add 4 to both sides. Yes, I know you could just look at that and tell, but that's how you do it. You set it to 0 and solve it. And whatever that answer is, that's what you can't use in your domain. So in this problem right here, the domain would be all real numbers except 4. Now, let's talk about the other case. What can we not allow if we have a square root? First of all, anytime you've heard me use this word twice already today. Under a radical, the stuff that's under a radical is called the radicand. This is the radical symbol. That is the radical symbol. What's under there is the radicand. Now, remember we said earlier, the radicand, what's under here, cannot be negative. The radicand can't be negative. The radicand can't be negative. Now, can it be 0? Yes. Can it be positive? Yes. So, think about this. What is another way of saying can't be negative? Wouldn't it be this? Isn't that saying the same thing? If the radicand can't be negative, then what can it be? Anything greater than or equal to 0. So, here's what we're going to do. If we have an x in the denominator, and I'm going to work these in just a minute. If we have an x in the denominator, we're going to set the denominator equal to 0 and solve it. And when we do that, we can't use that number. If we have an x under the radical, in other words, in the radicand, it can't be negative. So what we're going to do is force the radicand to be greater than or equal to 0, and those numbers you can use. You'll see what I'm talking about when I get to the examples in just a second. Now, if we don't have x in the denominator, and we don't have x under a square root, then the domain will be all real numbers. Okay, so, but you got to really study those notes to really get yourself used to those. All right, we're not going to do range of equations, just domain. So here we go. Write these instructions down. Find the domain of the following. Find the domain of the following. All right, here's the first problem. All right. Now remember, you can pause the video. Okay, so what's the first thing I told you to do before we even get started? To get the domain of an equation, get the y by itself. That's just what we always do first. So you have to get the y by itself. A lot of times that will already be done for you. Okay, Now, to get the domain, you have to ask yourself two questions. Is there ever any danger in this problem of dividing by 0? No, because there's no denominator. Is there any danger of imaginary numbers? No, because there's no square roots. So, in this problem, remember I said, if you don't have an x in the denominator and you don't have an x under a square root, then what's the domain? It's all real numbers. So the domain to this is all real numbers. Negative infinity, positive infinity. Okay, this next one. Okay, remember you can pause the video. Okay, let's solve it for y. So subtract the x squared across and then divide by 3. So you got to get the y by itself. Now ask yourself two questions. Do you have an x in the denominator? No. Do you have an x under a square root? No. Then the domain is all real numbers. And the way we write that is negative infinity to positive infinity. Okay, now let's look at this next one. Okay, this next one. First, do we have an x in the denominator? Yes. Okay, so we've got to make sure we get out our drink. Well, what would keep me from getting a drink? If you put something in here that causes the denominator to be 0. So here's what I ask myself. What makes this denominator be 0? Now, I know you can do this in your head, but I'm still going to show you the math behind it. So what you do is you take your denominator. You do not want your denominator to be 0. So take your denominator, set it equal to 0, and solve it for x. Solve this for x. Subtract 7. Now, that's not the number that you want. We're not solving the equation. We're not looking for a solution. We're looking for what x can't be. Well, if you let x be negative 7, that makes your denominator be 0, because you have 3 over 0. So your domain then would be all real numbers except negative 7. Now, in the homework, if he asks you to give this as an interval, here's how it's written. Negative infinity to negative 7, union negative 7 to infinity. Let me explain what that means. Think about, suppose this was negative 7 right here on the number line. You can't use negative 7. Well, what can you use? Everything on the left of negative 7, everything on the right of negative 7. All the numbers to the left of negative 7 is negative infinity up to negative 7. All the numbers on the right of negative 7 is everything from negative 7 and going on forever. This is a mathematical way of saying everything except negative 7. Now, one very important thing here. You do not put brackets on the negative 7. And the reason is if you put the bracket, you're saying that you're including it. And we're not. We're excluding it. Okay? So, this problem right here, do we have an x in the denominator? Yes, we do. So what do I need to do? I need to find out what makes this denominator be 0. I'm well aware you can do that in your head. If you look at that one, if you let x be 5, you've got division by 0. So the domain is all real numbers except 5. Now again, here's the math behind it. You're setting it equal to 0, and you're solving it, and that's the number you're throwing out. And so your interval now would be from negative infinity to 5, union 5 to infinity. Okay, this next one. And again, pause the video if you need to. Now, this one's a little harder to do in your head. Do I have an x in the denominator? Yes. What can I not allow? I cannot allow anything that would cause this denominator to be 0. Denominator cannot be 0. So, how do I find out what makes the denominator 0? Set the denominator equal to 0. And when you set the denominator equal to 0, that will tell you what makes it equal 0. Well, how do we solve this? This is a linear equation. Subtract 5 from both sides and divide by 7. Now, once again, when you find this number, that is the number that you can't use, because this is the number that makes the denominator equal 0. The denominator can't equal 0. So then the domain is all real numbers except -5/7. Now, on test, I'm fine with you just writing it out. All real numbers except -5/7. But that's the way you write that out. Okay, let's do one more like that one, or similar to this. All right, let's look at this one. All right, first ask yourself, do you have an x in the denominator? Yes. So if you have an x in the denominator, you have to find out what makes the denominator be 0. So set the denominator equal to 0. Okay, this should look familiar. This is not a linear equation. This is a quadratic equation. How do we solve a quadratic equation? By factoring, or the quadratic formula. This one factors is the easy case. X and X, signs are different, largest negative. Two numbers multiply 28, subtract -3 is -7 and +4. Now take and set both of these equal to 0. And when you get those two answers, those are the two numbers that X can't be. X can't be that. Now let me show you this on the number line. All right, we cannot use -4. We can't use that, and we can't use that. What can we use then? We can use all the numbers over here, all the numbers in between, and all the numbers to the right of 7. So how do you write all of the numbers over here? That's -infinity to -4. Union, or comma. Now, how do you write all the numbers in between? That's everything from -4 to 7. And then how do you write everything to the right of 7? Everything to the right of 7 is from 7 to infinity. Still finding domain. Now, notice on all three of these, they were all solved for y. So I didn't have to do that. All right, let's keep going. 4 more examples to close out this video. All right, let's look at this one. All right, ask yourself 2 questions on domain. Number 1, do I have an x in the denominator? No. Next, do I have an x under a square root? Yes. So what can I not allow? I cannot allow this to be negative. I don't mind it being 0. I can't allow it to be negative because that's imaginary. So if I can't allow it to be negative, what do? I force it to be greater than or equal to 0. So you take your radicand, what's under the radical, and you force it to be greater than or equal to 0. And when you do, that is your domain, because it's solved for x. The x is by itself. So your domain is not everything on both sides of 0. It's just everything on the right side of 0. But it also allows you to use 0. Greater than or what? Equal 0. So the domain is all the numbers 0 and bigger. Not both sides of 0. All right, let's look at this one. Do I have an x under the square root in the denominator? No. Do I have an x under a square root? Yes. So what do? this what's under here cannot be negative. So what do? I force it to be greater than or equal to 0. But when you do that, you have to solve this for x. You got to get the x by itself. How do I get the x by itself? You add 5 to both sides. If I add 5 to both sides, I get x greater than or equal to 5, and that's your domain. Now, just show you right quick. Pick any number 5 or bigger and put it in here, and you'll get out a drink. You get an answer. But pick any number smaller than 5. Well, let's take one. Take a number that's not bigger than 5. Take 4. If I take 4, 4 minus 5 is -1, and the square root of -1 is imaginary. And remember, that's not plottable in an ordered pair. So you pick anything smaller than 5, even 4.7, a decimal smaller than 5, and you'll get out a negative answer there. So that's your domain. All right, next one works the same way, so I'm going to hurriedly go through this. So you take what's under the radicand, set it greater than or equal to 0. All right, when you do, subtract 12 from both sides and divide by 3. And when you do, that's your domain. So that one's exactly like the one above it. All right, last example here. Works the same way, but I need to remind you of something. This one right here. Do you have an x in the denominator? No. Do you have an x under a radical? Yes. So what have we got to do? We got to force the radicand to be greater than or equal 0. X is on one side, numbers on the other. Subtract 6 from both sides. Now this is the part that you may have forgotten in inequalities. Remember, in an inequality problem, if you divide by a negative, remember you have to flip your symbol around. So your domain now is all the numbers less than or equal to 3. So the domain there would be negative infinity up to 3. So on this one, you pick any number 3 and smaller. And again, if you don't believe me, try it. Pick any number you want to smaller than 3. You won't have any trouble. But you pick any number bigger than 3. Let's take one. Let's take 4. If I take 4, 2 times 4 is 8. 6 minus 8 is a negative number under that square root, which I cannot have. So that's your domain. So we have done domain and range and function of ordered pairs, domain and range and function of graphs, and then we went to equations and we did function and domain. We are not going to do range of ordered of equations. Okay, so this concludes not this section, but that includes those 3 main topics that I talked to you about initially in video 1 of this section. Still in the same section, next video, but we're going to move on to other things.